Well, now we're doing Unit 7, Part 2, and again we're dealing with combinations where order is not important, and the formula is n choose r, and we've got n factorial in the numerator, the difference of n minus r factorial in the denominator times r factorial. So in 6, we're told in a certain lottery, 3 different numbers between 1 and 13 inclusive are drawn at random. These are the winning numbers. If you choose 3 different numbers at random between 1 and 13, what is the probability you will match the winning numbers? Assume that the order of the numbers is unimportant. So, we're talking probability 1 winner, and the total number of outcomes is 13 choose 3 possible outcomes. So when we invert and multiply, we get the 10 factorial upstairs, and 3 factorial is 3 times 2 times 1, but 2 times 1 is 2, so I am not going to write the 1 down. Anyhow, downstairs we've got 13 factorial, which is 13 times 12 times 11 times 10 factorial, and these 10 factorials divide out, and 3 times 2 is 6, which goes into 12 twice. So now we have 13 times 2 times 11, and all under 1. As this is 1, and now the product in the denominator is 286, so the probability of winning is 1 over 286, and the selection is A. Now for 7, I beg your pardon, we've got an interesting problem, and that's this. If you flip a fair coin 10 times, would you be surprised if the coin comes up the same way every time? What would be the probability? Well, I called this part A, and so the probability equals 1 win over, and instead of 2 to the 10th, we have 2 to the 9th as the total number of possible outcomes, because the first flip doesn't count. Here's why. The first flip establishes what's to be matched, either heads or tails. All subsequent flips have to either match that, heads or tails, and those subsequent flips, how many of them are there? Well, or how many possible outcomes are there? There's going to be 2 to the 9th possible outcomes. And so that's 0.01 over 2 to the 9th is 0.00195. Now for part B, which is the second part of this question, if 2,000 people all flip a fair coin 10 times on average, how many people could be expected to get the same thing all 10 times? And so the expected value is the number of events times the probability, and that product turns out to be approximately 4 people. Now for 8, explain what is wrong with the statement, "It's amazing that someone won the $100,000 prize in the lottery tonight. The probability of winning $100,000 is only," and we've got a point and 6 decimal points, 6 zeros before 512. And so it's not unusual. There are many people playing, and it's very likely that someone will win. Now for 9, there are 5 women running in a race. If a person guesses randomly the first place, second place, third place winners, what is the probability that they will guess all winners correctly? So the probability is going to be 1 over, and the arrangement, the order is important now, so 1 over 5p3 permutation equals 1 over, or probability equals 1 over 5 permutation 3, which is 1 over 5 factorial divided by, and 5 minus 3 is 2, so that's 2 factorial. When you invert and multiply, 2 factorial is 2. And now 2 goes in the numerator, and the 2's will divide out, and we get a 1 here. And 5 times 4 is 20, times 3 is 60. So the probability is 60, which is, by the way, that's A. And did I identify the right selection for 7? Excuse me. Yes, for 7. I beg. For 7, no, that was, there is no selection there. But for 9, we have a selection, not A, D, I beg your pardon. Wrong choice, D. Now we've got that right. Okay, we'll go on to part 3.